Hello and welcome to the session. In the last video we have seen we had a quick introduction to what is a decision tree. In today's session we will quickly go through ID3 decision tree. We will see the algorithm, we will understand how we can construct the decision tree using ID3. We'll also try to understand the math behind this decision tree. So let's first see what is ID3 decision tree. See, last session I just quickly gave you an introduction to what are the different types of decision tree. I'll just show you the slide. So the different types of decision trees are ID3, C4.5, cart, shared, quest, guide, cruise and C-tree. Today we are just going through the most popular decision tree, that is ID3, which stands for Iterative Dichromatizer 3 decision tree, which was developed by J. Quinlan in 1986. So basically ID3 tree is a supervised learning algorithm which uses training data sets with labels and it constructs a decision tree. So it is an example of univariate decision tree. Why is it called univariate? Is because it considers only one feature at each decision node. So at every node we will make a decision but based upon only one feature. So that's why it's called univariate decision tree. It is used to classify the future test instances. It uses a greedy approach in a top-down fashion by identifying the best attribute at each level of the tree. So at each level we have to make the decision to split the nodes. There we identify the best attribute to make the decision. Now this works for both discrete values as well as for categorical values. And suppose I have continuous values, then I attribute the feature or I partition the attribute by basically discretizing it. We build the tree using a purity measure called as information gain. So basically I'll be taking decisions based upon the information gain value. So ID3 is basically applicable only for classification with nominal or categorical values. ID3 will not work, this decision tree will not work suppose if you have missing values in your training data set. And ID3 is very good when you're working with large data set. Suppose you have a small data set, then usage of ID3 can result in overfitting issues. And one thing you have to remember is when we are constructing the tree, we are not going to prune. No pruning is done. That means we are not going to remove any part of the tree in order to avoid overfitting. So there is no pruning here and therefore it is prone to outliers. So there are other two types of decision tree which are also popular, that is C4.5 and cart, which we'll be seeing in the next few sessions. So basically these two decision trees can handle the missing values and the cart can handle outliers, whereas C4.5 can also, even C4.5 cannot handle the outliers. So let's see the procedure to construct a decision tree. See, first step is you have to calculate the entropy information. Okay, now what is entropy? We have seen in the last class. Basically it is the amount of randomness. We also saw the formula is in the last video. Please refer to the video in the description box. So first step is compute the entropy information for the whole training data set. For the entire training data set, for the complete training data set, we are going to calculate the entropy information and this is a formula. So the formula for calculating the T means entire training data set. For the entire training data set, I will calculate the entropy information, that is minus summation of pi log of pi, where I ranges from 1 to m. That is basically the number of training data sets. Next, you have to calculate the entropy information and information gain for each attribute in the training data set. Now there are various attributes in your training data set. For each one you have to calculate entropy as well as information gain. So the calculation for entropy information is, now you write T comma A, because A is the attribute and T is a total number of attributes. So the formula is summation of I is equal to V to A, where AI by T, where AI is the attribute for which now I am calculating the entropy information. T is the total training data set into the entropy information of that particular attribute. We also calculate the information gain as entropy information, that is which we have calculated into the step 1 minus the entropy information which I calculated in step 2. So basically subtract the value which I calculated in first step with the second step. That would give us the information gain. The third attribute is now how do I decide, how do I split the attribute, which is the best attribute for splitting. So choose an attribute which is having minimum entropy or maximum gain. See, now entropy and gain are inversely proportional to each other. So either you choose a attribute which is having minimum gain or which has the maximum gain. So that attribute would be chosen, the attribute with the most minimum entropy or the most maximum gain would be used for the as the best split attribute. So best split attribute is now placed on the root node. So first thing is you have to decide the root node. So to decide the root node, we have to do all these first three steps. Find out the entropy information for the total training data set, find out the entropy information and information gain for each attribute, and whichever attribute has the most minimum entropy or the most maximum gain, that attribute you choose as your root node. Next, you split the root node into subtrees, right, based upon the outcome of the test condition. So go on now splitting the nodes. Now this will be a recursive process. After splitting, again you have to find the entropy information gain to again take the node which is having the maximum gain as the next node. So it will be a recursive process until we reach the leaf node. Now, how do I know that I have reached the leaf node? So leaf node means that's the end of branching. So if I get the node, right, you can stop branching if the entropy is 0. That means I have reached a node where if I am getting the entropy value as 0, I am calculating the entropy at every step. When I get the entropy as 0, so that means that node is the leaf node. Or if I get the maximum information gain, then that node would be the leaf node. So that would be the condition when I am choosing the leaf node. You get a node, you calculate the entropy, you get the entropy which is 0 or the most minimum, then that would be your leaf node. So let's see the math behind this. So let's say T is the training data set. And let's say the attributes I have here is A1, A2 up to AN. And A is the set of all the attributes. Let's say M is the number of classes, which I'm going to basically use to classify my training data set into. And say Pi is the probability that a data instance or a tuple D belongs to class Ci. So how do you calculate the probability is total Pi is equal to total number of data instances belonging to class Ci in T divided by total number of tuples in the training set T. So mathematically Pi is dCi by T, mod of dCi by T, where dCi is the total number of data instances belonging to the class Ci and T is the total number of tuples in the training set. Now the expected information or entropy is denoted as, this is a entropy information formula which I just showed in the previous slide. You have calculated the probability, put that value here. So summation of Pi log of Pi and negate it. So that would be our entropy information. And entropy of every attribute has to be calculated. So that would be for every entropy information for every attribute is attribute value divided by the total value into entropy information of that particular attribute. So that is what we discussed in the last slide. First find the entropy information for your entire training data set. Next find the entropy information for every attribute in your training data set. Then based upon that I will choose my root node. So once you have calculated the entropy information, you need to find out the next metric that I calculate is information gain. Information gain is nothing but the total entropy information minus the entropy information of the attribute. So we calculated this in the step 1, we calculated this in step 2. Just subtract these two, you get the information gain. So what you have to remember is entropy is inversely proportional to information gain. If the entropy increases, the gain decreases. This you need to remember. Okay, now I will choose my root node or my next best attribute based upon this value. Okay, the attribute which has the maximum entropy or the most minimum gain would be chosen as the best attribute. So let's meet in the next session where based upon this math we are going to do a formula or problem on ID3. So thank you so much and please subscribe to the channel. Thank you so much.